Good morning. Today, our topic is knocking. So, most of you might have traveled in bus, two wheeler, cars, isn't it? So, when we're traveling, we get some unbearable noise, somewhat like right, and that is called as knocking. Why we get so knocking in the terms? What do you mean by knocking? Right, so that is called as knocking. So do not. So same type of noise, some unbearable noise we get in two-wheelers, four-wheelers, anything, any vehicle, any automobile for that instance, right? So why do you get that type of noise? So before going to know what is the chemistry behind that, let us understand the working of engine here. So how does your four-stroke engine work? So you'll have four strokes. Okay, when an engine starts, when a petrol should go into the engine and it starts working, you'll have four stroke. What is the first stroke? The first stroke is air and fuel mixture will be sucked into the engine. That is the first stroke. Second stroke is compression of fuel air mixture. So we can see engine have two valves there, right? So during the first stroke, the first valve will be open, inlet valve will be open, whereas the exhaust valve will be closed. So as soon as the air and fuel mixture will be sucked in, both inlet and outlet valve will be closed. Second stroke, compression. So in the third stroke, it is called power stroke or ignition stroke. So a small spark will be produced and the fuel present in the engine will undergo combustion. So it undergoes combustion. What will happen? So as part of combustion, so it will produce this various gases, carbon dioxide, water, XYZ. So and energy. Energy will be used to push the vehicle front or back depending upon the driver's instructions, isn't it? Next, the gases which are produced should come out. So in the fourth stroke, the exhaust will open up and the gases will come out. So this is called as smooth combustion. If this occurs, what will happen? There will not be any noise called. There will not be any noise. That is called as smooth combustion. Then what is knocking? Why knocking occurs? Okay. So knocking occurs because, so you know petrol. So petrol is a volatile liquid. So it for this 20 degrees is sufficient to ignite. So what will happen? In the first stroke, as it is, fuel air mixture will be sucked in. Okay. And inlet valve will be closed. Outlet valve will be closed. In the second stroke, fuel air mixture will be compressed. When it's compressing, you know, we're applying pressure. When you're applying pressure, you know that temperature also will increase. Pressure is directly proportional to temperature. When temperature increases, automatically part of the fuel will get ignited. When the fuel ignites, what will happen? It produces so many various gases. What are those gases? We'll see there. It will not undergo complete combustion. So it in the way of undergoing combustion, it produces gases. Okay. So these gases, there is no place to go out. Hit the inner walls of engine and piston with high pressure, causing a rattling noise called as what? Knocking. So until the fourth stroke, so next is the third stroke, later is fourth stroke. But here the second stroke only partial amount of fuel undergoes combustion, and because of this combustion some gases will be produced. These gases, there is no place to go out, therefore it will hit the engine's inner parts of engine piston with high pressure like this. So because of this, it produces a unbearable rattling noise called as knocking. So until fourth stroke. In the fourth stroke, the exhaust will open up and gases will go out. So this is a continuous process, therefore we'll get continuous knocking. So let us see what is the chemistry behind that. What are those gases? XYZ. Okay. So compression ratio. As compression ratio increases, efficiency of engine also will increase. What is compression ratio? It is the ratio of engine before and after compression of fuel air mixture. It is the ratio of engine before and after compression of fuel air mixture. As compression ratio increases, obviously efficiency also will increase up to certain threshold. Later knocking will occur, or later the efficiency will be maximum. Okay, so beyond compression ratio, certain compression ratio, explosive combustion of fuel air mixture will results in producing thermal shock waves. So these waves hit the inner walls of engine and piston, producing a rattling noise. So what are these thermal shock waves? How it is produced, we'll see. Knocking. So thus knocking is defined as a production of rattling sound as a result of explosive combustion of fuel air mixture due to increasing compression ratio. So what is explosive combustion? We'll see. So if let us consider ethane as an example. If ethane in presence of oxygen, if undergoes combustion, it should produce carbon dioxide and water and energy. This is normal combustion. If this undergoes, as I told you in first, this is normal combustion and smooth combustion. So if explosive combustion occurs, so here under explosive combustion, what will happen? So knocking occurs as the chain reactions proceeds at faster rate, leading to the formation of number of gases. So explosive combustion, number of gases. So here these gases hit the inner walls of engine and piston under high pressure, producing a rattling noise known as knocking. This is explosive combustion. So what are these gases? For example, again we consider ethane. Ethane in presence of oxygen undergoes combustion. So in the second stroke itself, under compression stroke itself, what will happen? It will undergo combustion and it produces an intermediate compound, that is dimethyl peroxide. So this dimethyl peroxide further undergoes oxidation to give acetaldehyde. Acetaldehyde is a gas. Again this acetaldehyde undergoes oxidation to give you formaldehyde, and this formaldehyde finally undergoes oxidation to give you carbon dioxide and water. So all these three reactions undergoes where? In the compression stroke or power stroke. So during this acetaldehyde or formaldehyde will be in the form of gases. So these gases hit the inner walls of engine with high pressure and it will be with high temperature, right? When these hit with high pressure, what will happen? We get a rattling noise that is called as knocking. So until the exhaust is open, so this will undergo. By the time exhaust is open, what will happen? Formaldehyde will decompose to carbon dioxide and water, and this will come out through the exhaust. Okay. So why explosive combustion occur? Explosive combustion occur because when during the combustion stroke, pressure is directly proportional to temperature. That temperature is sufficient for the fuel to undergo combustion. So this ethane directly will not decompose to carbon dioxide and water. Instead, it will decompose to give so many intermediate compounds. So these intermediate compounds will hit the inner walls of engine and piston, leading to knocking. That is why knocking occurs in any type of engine. So there is any idle engine. So yes, so only the temperature is 273 Kelvin, it's 0 degree Kelvin, then we can obtain 100% efficiency. But it is impractical, right? So now let us see what are the adverse effects of knocking. So due to knocking, driving becomes unpleasant. So it produces an undesirable rattling sound, and efficiency of the engine will reduce. It increases power consumption and increases fuel consumption, and power output of the fuel is also decreased. So this, because formaldehyde may further oxidize to give formic acid, acetaldehyde may oxidize to acetic acid. So due to this, it may cause damage to engine parts also. So these are the effects of knocking. Now then, how to control knocking? Knocking can be controlled by using critical compression ratio. That's a maximum. It should not go beyond the threshold. So that the knocking can be controlled, and reducing inlet temperature, reducing inlet pressure. The pressure and temperature should be monitored. By that you can control knocking. And lowering the power output, increasing turbulence, decreasing flame travel distance, increasing engine speed, modifying spark plug location, compact combustion chamber, addition of anti-knocking fuel additives or anti-knocking agents. By these we can control knocking. So let us discuss what are the anti-knocking agents and what are the other methods to prevent knocking later in our next discussion. Thank you.